In this video, we're talking about chronic kidney disease, which is pathology of the kidney or failing of the kidney for more than 3 months. So let's jump in. This is all different things the kidneys do, and when it fails, this is the result. So 1, erythropoietin is a hormone that's secreted by the proximal convoluted tubule cells of the nephron. It goes into our bloodstream, it goes to the red bone marrow, and it causes erythropoiesis, which is stimulation of red blood cell production. So if you don't have that hormone being made by the kidney, you're going to end up with anemia. So symptoms like fatigue and pallor. Another thing that happens is electrolyte imbalance. Our electrolytes have to stay in a narrow range or it gets really bad. So one thing that happens with chronic kidney disease is the potassium levels will go up. It'll cause hyperkalemia. It'll cause hyperphosphatemia or high blood phosphate because the kidneys just aren't working correctly to keep the electrolytes where they need to be. So that can be really bad. Another thing is that it plays a big role in our acid-base balance. So if our kidneys aren't working, our alpha intercalated cells of our distal convoluted tubule and collecting ducts aren't secreting protons into the filtrate like they should, and the proximal convoluted tubule cells aren't reabsorbing the bicarbonate like we should, and that ends up in a metabolic acidosis, which can be a serious medical condition. Another thing, our kidneys clean the blood of waste, and the one waste product that builds up with kidney failure is uremia. So uremia is a byproduct of protein catabolism. It's basically getting rid of those amino groups, the nitrogenous groups, and it can build up, it can cross the blood-brain barrier, and it can actually cause mental status changes and other neurological problems, even leading to a coma. Another problem is that these proximal convoluted tubule cells, they produce an enzyme in response to parathyroid hormone called 1-alpha hydroxylase. 1-alpha hydroxylase. When vitamin D is being made, we'll synthesize it in the skin. It goes through a step-by-step process. It'll go to the liver and get hydroxylated on its 25th carbon. Then it'll head over to the kidneys and it'll get hydroxylated on the first carbon by 1-alpha hydroxylase. And it becomes 1,25-dihydroxy Vitamin D, and that's the active form of vitamin D. That goes to the intestines and causes our intestines to reabsorb calcium. So if our vitamin D levels are low, we're not going to absorb calcium from the intestines. We're not going to reabsorb calcium in our nephron because our kidneys aren't working. The only way we can get our calcium levels up, and this is what happens with chronic kidney disease, is we get Hypocalcemia or low blood calcium, is that we get Hyperparathyroidism, secondary hyperparathyroidism, secondary to renal failure. So we'll get this high level of parathyroid hormone, and it can't work on the proximal convoluted tubule cells. They're not making that enzyme. So it has to work on the actual bone, and it weakens our bones because it stimulates osteoclast to release acids and release calcium into the bloodstream and bring up blood calcium levels at the expense of our bone integrity. So we end up with renal osteodystrophy because there's that just perpetual high parathyroid hormone that is trying to keep our calcium levels up by demineralizing our bone. Let's see, I believe that's everything. You can measure the degree of chronic kidney failure by the GFR, glomerular filtration rate, and there's 5 different stages. And so it gradually gets down, I think under like 25 or 30, it's like stage 5. And at that point, you don't make a lot of urine, and it's a bad situation. You really need dialysis or a kidney transplant when it gets to that point. But that is kind of a good review of the physiology of the kidney, just kind of going in reverse and what happens when pathology rises, and we'll see you in the next one.